This video is going to show how to simulate repeated exponential electrical fast transient, or EFTs, in PSpice Designer. EFTs are often caused by events such as switching inductive loads, relay or switch context bouncing, or lightning strikes, which can introduce high-frequency noise into electrical systems. Simulating EFTs will help ensure your design performs as intended when subject to real-world disturbances, potentially averting a redesign. EFTs are simulated as a series of pulses created at a certain interval, then held, then repeated after a longer period. For this example, we will create an exponential source that creates 20 pulses 20 microseconds apart every millisecond. Open the provided design in OrCAD PSpice Designer 24.1. To place the source, select Place Component from the menu. The Component Explorer tab opens to show a list of available components. Select PSpice as the category and enter VEXPB into the search bar. Press Enter to list the results. Double-click the VEXPB component. Click to place the exponential source in the empty space in the schematic. Right-click and select End Mode when finished. If you are running PSpice 23.1, the burst exponential source is not listed in the Component Explorer. Select Place Part from the menu. Select Add Library under Libraries. Select the source library and click Open to open the parts list. Select VEXPB and click Place Part. Click to place the part in the empty space, then right-click and select End Mode. With the source placed, its parameters must be defined before it can be simulated. Right-click the source and select Edit Properties to open the Property Editor tab. Here, all properties of the component, including simulation properties, can be defined. Select the cell for V1, the minimum voltage level. Enter 0 for a rest state of 0 volts. With the same method, define the maximum voltage level, rise time constant, fall time constant, rise delay, and fall delay. The burst parameters must also be defined. Select the cell for pulse period, labeled PER, and enter the pulse period. In this example, we will repeat the pulse every 20 microseconds. Select the cell for the number of pulses, labeled NPUL. Enter the number of pulses to repeat in a single long cycle. Lastly, select the cell for the repeat burst period, labeled PERB. Enter the period to wait between pulse groups. Click Apply and close the Property Editor tab. With the pulse parameters configured, we are ready to run the simulation. Select PSpice New Simulation Profile from the menu. Enter a name for the simulation profile and click Create. If the Product Choices window opens, select the appropriate license and click OK. Set the run-to time to greater than the defined burst period. In this example, we will set our runtime to 10 milliseconds. Leave the other settings as the defaults and click OK. To probe parts of the circuit to display in the simulation results, select the Voltage Level Marker button from the toolbar. Click to place probes at the main input and output nets. Right-click and select End Mode. We can now run the simulation. Select PSpice Run from the menu to start. View the results. The exponential pulses are shown repeating 20 times 20 microseconds apart for each 1 millisecond period. To get a closer look at the pulses, select Zoom Area from the toolbar. Click and drag to select one of the pulse periods and release the mouse to zoom in. The exponential rise and decay is clearly visible. Simulate repeated exponential EFTs in PSpice Designer to ensure the reliability and robustness of your PCB designs. For more tutorials, visit us at resources.ema-eda.com, and don't forget to like and subscribe to our YouTube channel.